of math. Okay, hopefully you're here to learn something. That's cool. Okay, we are on Unit 1, Day 2 Notes. And this is 2020. Woohoo! Okay, again, today's stuff's just a little bit of review from some things we've done in the past, or that you've done in the past in algebra. My name is Mr. Krause, but for the next, 45 minutes, you can call me Mr. Key, because I got all the answers. All right, let's take a look. What do we got here? Domain. Don't forget, domain are the input values, otherwise known as the X. And the range of the out, that's behind my big fat head. Range of the output values, or the Y's. And if I was to take a look at this, and I asked you for the domain, remember we're going to look at the X values. And I'll do these in order. So 120 is the lowest. And it's down there twice, so I'm not going to count it. 130. 240, 260, and 295. And then the range, so this will be the domain, and the range, let's see, what's the lowest? 929? 930? I don't know why I get my head that close. 977, 982, or wait, oh, that's 882. Oh, is that 882? Okay, 882 should have gone here. Old eyes couldn't see it. 988 and 991. I guess you get the picture, right? Pretty simple. Is it a function? It is not a function because we have repeating X values. Domain here, remember we don't repeat domains, right? We don't repeat domains. So it's 1, 2, 3, 4. Just because there's two of these, we don't repeat it. So 1, 2, 3, 4. Range, we also don't repeat range values if we have repeating range values. So there's 1, 2, 3. I know there's two of them there, but we don't repeat it. 4 and 5. So 1, 2, 3, 4, 5. Alrighty, let me take a quick break. Sorry, something's wrong with my computer. Alrighty, let's get going. What we got here? Let's keep moving. Sorry about that. I don't know what's going on with my computer. Anyway, we're going to graph this function f of x. Now, I can use my calculator if I want, but I hope you guys remember that the slope is just going to be equal to negative 2 over 3. And the y-intercept is, what is it, negative 4. Okay, so we're going to put a point down here at negative 4. And we go down 2 into the right 3. So it looks something like this. Now, something that's really funny is trying to watch me draw a straight line using this. If I had a touch screen, this version of OneNote actually has a ruler in it. But I don't have a touch screen, so that's the best I can do. You should use a straight edge. Anyway, there it is. Identify the domain and the range. So, domain is the set of all reals. The way we're going to show that here, and I'm going to talk about it in a couple of minutes, is from negative infinity to positive infinity. I know you've seen this before. And the range is also all reals. And I would say from negative infinity to positive infinity. You can say it either way. Now, we're going to get a little fancy at some point. We're going to say domain is that you could also say X is in the set of all reals. And then range, you would say Y is in the set. Oops, that's not in the set. It's just a weird looking E. In the set of all reals. And usually we would put that in curly brackets. All right, I'll show you on the next page. So, if we're talking about inequalities notations, then we will use less thans or greater thans. And these are ones that are, so you know that's less than or greater than, but remember that these are the ones that are not equal to. And if I use less than or equal to or greater than or equal to, these are the ones that are equal. Got the A, equal to. Now in interval notation, it's just a different kind of notation. We use parentheses to represent not equal to. Or brackets to represent equal to. And you'll see what I mean in a second. So let's take a look at what this says. This says that x, so we're going to start at -2. X is greater than that, but less than infinity. Another way to write this would be x is greater than or equal to 2. These two things mean the same thing. So because at 2 I have an equal to, I'm going to put a solid circle. And I should have put that back up here in the notes. So if you have equal to, these are open circles, and these are solid filled in circles. Right? So not equal to have the open circles, closed circles have the equal to. And since x is greater than, I'm going to put an arrow to the right. Now how would I do that in interval notation? So here's what I want you to remember for interval notation. This is inequality notation. For interval notation, I want you to remember to put a comma. And on the left side, you're going to put the small number. Always has to be the small number, and this has to be the big number, or the large number. So the small number is 2, and the large number is infinity. Then I come over here and I say, okay, I don't know why I just did that. I come over here and I look at this and I say, okay, does it have an equal to? Oops. It has an equal to, so on the 2, I'm going to put a bracket. Now, the idea about infinity, you can never, ever, ever, ever find or get to infinity, which means you will never reach infinity, which means you can never equal infinity, right? Anybody ever play that stupid game with your kids? I'll bet you infinity. I'll bet you infinity, infinity. I'll bet you infinity times infinity. You know that stupid game? Am I the only loser that played that one? All right, so this is going to be basically the same thing, except now it's not equal to. So it's an open circle now at 2, arrow going to the right. And if I did that in interval notation, small number, comma, big number, we can never reach infinity. So anytime you draw an infinity or write an infinity, you have to have a parenthesis. But since it does not have an equal to here, I put a parenthesis. Can't equal that. All right, now these are going to be basically the same thing. I don't know why I keep saying basically. I hate that word. But it's in reverse. So now we've got an equal to. So we're going to do a solid circle at 2. But now we're going off into this direction. Now x is less than this. I could rewrite this as x is just less than or equal to 2. I don't need this part right here. It's just designed to help you when we get to interval notation. So again, small number on the left, big number on the right. Now, negative infinity is the smallest number there is. Negative infinity can never go on the right because it's small. It's really small. So negative infinity always has to go on the left and put a parenthesis. We're going to put a 2 here, and because we had an equal to, we have to put a bracket. And this is going to be the same thing, but just with an open circle. And now negative infinity on the left, small number on the left, big number on the right. You can never equal infinity or negative infinity, and because we do not have an equal to here, it's a parenthesis. All right, let's take a look at a couple of different ones. All right, I'm going to look at this piece first. This piece says at -4, we've got an equal to, so we're going to put a solid circle. At 2, we've got an open circle because we do not have an equal to. And x is above this but less than this. In other words, x is in the middle. Now these are the easiest ones for interval notation because I put a comma here and I look, oh, there's the small number, -4 goes on the left. There's the big number, 2 goes on the right. Now, we got to go back and look for equal to's or not equal to's. We've got a solid circle and we have an equal to, so we're going to put a bracket. We got an open circle here and we don't have an equal to, so we put a parenthesis. All right, this one's got 2 pieces. And I'm going to introduce you to a new some new notation is what I'm going to introduce. So we're going to look at just this piece first. So -2, open circle. 1, closed circle. And x is in between those. So I'll do that. Now, if I was just to quickly come over here and do the interval notation for those, for just that one. Whatever, keep flowing. I'm just going to do that piece right there. Put a comma, small, that's a comma. Small number on the left, -2. Big number on the right. The 1 has a closed circle, so we put a bracket. And the -2 has an open circle, so we put a parenthesis. Now I'm going to work on the other piece. This says x is greater than 2. So I'm going to come over here, put an open circle at 2. Greater than would be going to the right. So I'll put a comma here. Small number on the left, 2. Notice it's going off to infinity. Anytime you have an arrow, you're going to have infinities. So small number on the left, 2. Infinity on the right. Can never reach infinity. And 2 has an open circle, so we're going to use a parenthesis. Now, you cannot write the word or in here. So, as I look at this word or, in interval notation, the symbol is U. It stands for union. So, this in interval notation is the U. So, anytime you give me interval notation and there's an or in it, you got to give me the U. And this one's going to have one as well. So, let's take a look at this one. We've got an open circle at -2. Actually, it's a closed circle at -2. And we're going less. In other words, we're going this way. This one has a closed circle at 1, but we're getting greater, so we're going in that direction. By the way, you'll never have this. If you ever have two arrows going like this, you screwed up. Okay, so you never have the arrows going in, pointing in two different directions. You're either going to connect the dots, or you've got arrows pointing in opposite directions. Okay, so if I just look at this piece for interval notation, I put a comma. Anytime you have two distinct pieces, you're going to have an or. You're going to have one here, the union symbol, and then one here. Okay, so the big number is -2, and the small number is negative, oops, going to jam that in there, negative infinity, because we're going off to infinity. Can never reach negative infinity. The 2 has a bracket on it. It's an or, so I'm going to put the union symbol, comma. Now this one has 1. Now I'm going to do this piece. 1 is the small number, positive infinity is the big number, can never reach infinity, and the 1 has a solid circle, so a bracket. All right, so let's talk about domain and range when we look at graphs. So domain deals with the left and the right. Range deals with the up and down. So if I look to the left, these are your x values along here, right? These are my x values. Isn't this thing going forever and ever and ever and ever and ever to the left? So it's going forever and ever to the left, so it's negative infinity. It's also going forever and ever to the right, so it's going to positive infinity. So my domain is negative infinity, comma, positive infinity. Now, as far as range goes, we got a little bit different. Range is the lowest value down and the highest value up. So if I look down here, this is the lowest point on the graph, and that's at -3. And it looks like I got a solid circle there. It's always a solid circle unless you see a circle like this, an open circle. And how far up does it go? Well, it goes forever and ever up, so it's going towards positive infinity. So small number on the left, big number on the right. So -3. Infinity. You can never reach infinity, so you always have to put a parenthesis. Now, if I look back at the graph here, right, I don't see an open circle there, so I know that's a bracket. All right. I'm going to tell you right now, generally with domains, it's almost always negative infinity and positive infinity. I know this looks like it's going down, but you also have to imagine that very slowly it just keeps going and going and going to the left. This one looks like it's going down forever, but it's also going in that direction. So it's going forever and ever left, forever and ever right, negative infinity to positive infinity. The range is almost always the more tricky of the two, right? So we look for the lowest value. The lowest value, it looks like it's going down to negative infinity. And the highest value is up here at 2. Now remember, when you're doing interval notation, it's always small on left, big on right. So negative infinity on the left, can't reach that, comma 2. You don't see an open circle there, so it's a bracket. Now, this is not a function, but we can still talk about its domain and range. It's just the domain and range of a circle. So how far to the left I go? Negative 3. How far to the right did I go? 3. They're not open circles, so small number on the left, big number on the right, and brackets. Pretty straightforward. Low number is negative 3, high number is positive 3. So believe it or not, the range and the domain for these are exactly the same. All right, this one should be easier to see. It's going forever and ever to the left, forever and ever to the right, negative infinity, positive infinity. But as you can imagine, it's also going slowly up and slowly down forever and ever. So it's going forever and ever down and forever and ever up. So negative infinity to positive infinity. You've seen piecewise function before, right? We're going to talk about this as the year goes on. But I know you've seen piecewise functions. I need to take a quick break to get a quick save in, and I'll be right back. And a drink of water. All right, so here we go. Let's take a look at this one. I see that as I come, let me use the rainbow. As I go here, I'm using all these values. There's no breaks and there's no stops. So my leftmost value here is negative 1. My rightmost value here is 3. And there's no breaks or jumps or anything in between. So those are the left and right. Now, I also see a solid circle and a solid circle. So I'm going to do a small number on the left, big number on the right, and both brackets. Now I'm going to look for how far down does it go and how far up does it go. The most it goes down is here. There's no breaks, no holes, and this is the highest it goes. So the lowest it goes is negative 1. The highest it goes is positive 1, and since those are solid circles, we'll do the same thing. Now this one's got a jump in it, and when you get into pre-calc and calc, they'll talk about points of discontinuity and jumps and all that stuff. What we need to see, though, is it looks like it's going forever and ever in this direction, which means it's going forever and ever left. And I want to make sure I haven't missed any values. So I'm using all these values, I'm using all these values, and using all these values. I am using 1. At 1, it comes up here. Now, there's an open circle here, but I did use 1 right here, and I'm using all those. So that's just negative infinity to positive infinity. We're going to get to some weird ones in a minute. Now, if I look at the lowest value being used, it looks like the lowest value is 0. And it looks like it's going up forever and ever and ever. But I see this little break here. So am I not using those values, or am I? In other words, do I ever use the value 1.5 for y? I don't use it over here, but I do use it over here. 1.6, 1.7, 1.8, 1.9, whatever. I use all those values. I am, in fact, using all of these values in between. So it's going right to infinity. 0 is the small, infinity is the big, can't ever reach infinity, and 0 is a solid point on the graph. Now this is called a step function, just so you know. It's called a step function. It should be obvious why we call this a step function. Looks like steps. So I'm going to look at the left. The leftmost number is negative 2. The rightmost number is 2. But did I use all these values? So I used all of these until I got to negative 1. But hey, wait. I used negative 1 here, and I used all of those. But I didn't use 0. But wait, I used 0 up here. I didn't use 1, but I used 1 up here. So yeah, I used all of those. So from negative 2 is the small, 2 is the big. At negative 2, I got a solid circle, so that's a bracket. At 2, I got a open circle, so that's a parenthesis. Now, this one is very, very tricky for this one. The lowest number used is negative 2, and the highest number used is 2. But those aren't really going to help you in this particular case. And the reason they're not is, and let's see if I can just blow this up a little bit. The y values for all of this are 2. So the y values for all of these are 2. The y values for all of these are negative 1. The y values for all of these are 1. And the y values for all of these are 2. But notice I did not use any of these y values. I did not use any of these y values. Like, never once did I use the y value of a half. And I never used these y values. Anytime you see that, oh, we got -2, -1, 1, and 2. Those are discrete numbers. And I think I prefaced this yesterday in my day one notes by saying anytime you have discrete numbers, you're going to give me your answers in curly brackets. -2, -1, 1, and 2. In other words, it's not a smooth, continuous curve. It's -2, -1, 1, and 2. And that's how we have to define that range. All right. We're almost done, right? Much shorter notes today. All right, so what I'm doing here is I just want you to tell me, what do you think would be an appropriate range for a bird's first flight? Now, if you remember anything about a bird, you know, a bird's got a tree. We got a little bird's nest up here, right? Little birdie's up in the tree. I know I'm a ridiculous artist. Pretend that's the birdie in the tree. And the birdie's first flight is fly, 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 boom. Right? Pretty much they just flap their wings and hit the ground, right? Because they cannot, as far as I know, birds don't know how to fly on their first flight. They have to learn how to fly. So if I was to think about the domain and range for a bird flying, right? So it's starting up in its tree. So remember, up and down is range. In this case, notice my domain value is t, which is time. Time. So what's the time for a first flight? How long? So we're talking about domain. What would be the time for a flight? I don't know. 5 seconds? 6 seconds? How long would it take? I don't know. How long would it take to fall out of a tree? You know, flap, 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 hit the ground, right? 3 seconds, 4 seconds. So if I was thinking about it, first of all, the lowest amount of time when it's just about to start is 0 seconds. I don't know, maybe 5 seconds. Oops. First flight, 0 to 5. And I would put a bracket here. Let's just say, who knows? Remember, this is just an estimate. And then range. Well, how big are trees? What could be the range of a bird's first flight? Well, first of all, what's the lowest value? The lowest value is 0, so that's easy. It's going to hit the ground. And the highest value is, I don't know, 100 feet, 50 feet? I don't really care, as long as you have an idea that what those are talking about. Let's talk about this dude. A student may only work 3 hours, not work more than 3 hours, Monday through Friday. Well, they may not work more than 18 hours per week when school is in session. They may not work more than 8 hours per day. If a student works a job and they're paid the minimum, so they're going to get paid $8.75 an hour. Boy, I should really update that. I think it's up to 12 something. Wow, it really has shot up since I wrote that. That's crazy. What is the approximate domain for wages working in school? So let's assume that they're going to work 18 hours. So wages are wages. W of t is the range. That's the wages. So the range is the W of t. That's your wages. And the domain, I should have put this over there. The domain is the time. So what's the lowest amount of time an employee can work if they're 14 or 15 years? The lowest they can work, and actually anybody, is 0 hours. They can say, oh, I'm not giving you any hours this week. We've all had that. Or I can give you up to 18 hours. So 0 to 18. So my range, which is my wages, my W of t is my range. Well, if I work 0 hours, I make 0 cash. And if I work 18 hours, 18 times 8.75, the most I can make is $157.50. So if I work the least amount of hours, I'll make 0 cash. If I work the most amount of hours, I make $157.50. All right, last problem. Dominic and John are practicing for the sectional baseball game. If the two boys are throwing the baseball back and forth, let h of t represent the height of the ball in feet as a function of time. What would be the approximate domain and range for a function? This is always interesting. So h of t is the height of the ball, but this is also the range. T is the time, and this would be the domain. So let's say we've got really, really good baseball players, and they're playing catch. Well, what would be the time of the flight of the ball? Well, the lowest amount of time just before Dominic lets go of the ball is 0 seconds. Now, how long can somebody actually throw a ball in the air? Like I always had some kids put 50 seconds. The only place you're going to throw a ball that's in the air for 50 seconds is on the moon. You can't do it any other place, so that's not going to work. So we're going to throw the ball. How long? 2, 3 seconds? Okay, let's say they're really good and the most they can do is 3 seconds, right? It's not going to be 5 or 6 seconds. 1001, 1002, 1003, 1004, 1005. I don't know. That's a long time in the air. Range? Now here's a little bit different one. If you're throwing catch, and let's say you're like 3 feet, 4 feet, 5 feet. Oh, it's sectionals, right? So sectionals. So that means they're high school kids. So a high school kid's probably at least 5 feet, 6 feet tall, right? So what would be the lowest ball height? Let's assume they catch it. Maybe they catch it a little bit lower, later catch it a little higher. But, probably the lowest is 5 feet. If I throw it in the air and I make a nice arc, maybe it goes 15 feet in the air. I don't know. If you throw it too much arcing, I don't know. It's not 0 unless they don't catch the ball. I guess you could throw grounders at each other, but that's not really practicing catch. That's just practicing grounders. And I didn't say practicing grounders. All right. That's it, kids. That's the end of day 2 notes. Catch you all on the flip side. Hey, make sure you subscribe to the channel. I got to talk about that in my videos, okay? Thanks, guys. Take it here. Bye.